Hi, I'm Dave Neum, and this is the second video where I explain the technology behind my winning Internet of Things prototype from the 2015 New York City TechCrunch Hackathon. This device will detect if your stove is on and will send you a text message if you need to check it when you're away from home. I designed and built this in 24 hours for the event. There are three main components to the device. The first part is the temperature sensor. That will detect whether your stove is on or off. The second component is the Wi-Fi module. That will connect to your home network, and that will send all the information out to the internet. And the third component is the microcontroller, which coordinates between the two. Now, right now, the temperature sensor is detecting that it's about 73 degrees, which is about room temperature. When the stove top turns on, there will be a blast of gas and heat that will shoot out from underneath this water boiler. When that temperature wave hits the temperature sensor, it'll raise the temperature up to the threshold point where the device will say, okay, the stove is on, and then it will push a text message through the Wi-Fi out into the web. So let's go ahead and turn on the temperature sensor and the stove. So right now the stove is on, and the temperature sensor detects 149 degrees Fahrenheit. That indicates that the stove is on. The program just said that it's going to push its SMS text message to the phone. And the phone just got the message. And let's take a look what it says. And it says, "Yo, Shell, your stove is on," which means that Sheldon's stove is on, and wherever he's monitoring it, he really should come back home to check to see what's going on. Now, if we take a look at the program that's running over here, you can see the difference. It started off at 78, 74 degrees Fahrenheit, which is about room temperature. And then when it finally detected that the temperature went up, it was 158 degrees, and that's when it pushed out the SMS text message. Now, while this part is important for the device, what's actually really important in terms of functioning is that we had to use two APIs. One is called Tembu, which is at tembu.com, and the other one's at Twilio, twilio.com, which sends out the SMS message. Now, Twilio requires that all your messages are encrypted using SSH or SSL. The problem with the microcontrollers, because it's so small, putting an SSH library on there is really large, so it slows down the functioning, and a lot of times you can't fit it in. So what we did was we used Tembu's API to do the encryption for us. Tembu took the message from the Wi-Fi module, it encrypted it, and then sent out the encrypted message out to Twilio. And then Twilio authenticated the message, saying, okay, this actually is coming from the stove in Sheldon's house, and then it shoots out the SMS message to his phone. So now we know for sure the origin of the message, we know where it's supposed to go, and everything's been encrypted, so that way it's not hackable, at least in this state. Once Sheldon got the message, he can look at his phone and say, oh shoot, I gotta go home and check my stuff.